Can we start? Can we start? Yeah, good evening. Good evening, Soumya. Yeah, let's start now. In the last class, we see in the last class we see in recursion. Right. In last class, we see in the recursion. Right. Now let's continue this. Let's wait few minutes because I given the link little late. So let's wait few minutes. We can start at 7 o'clock. Dinesh, we can start the class at 7 o'clock. I given link little late. Yeah, at 7 we will start. Yeah, so Soumya and Dinesh, post in our group. In our group post, ask them to join. In our group, you can post and you can ask them to join. Where is Goyal? Yeah, fine. Let's go ahead. Let's go ahead now. Recursion. So in the last class, yeah, we given enough time because I'm little late in the posting this link. So I given enough time to join. So I think I'm starting now. In last class, I explained to you what is the recursion. In last class, I explained to you what is the recursion. Yeah, fine, that's okay. In last class, we discussed about recursion and some points. So I'm reminding all of them one time. Recursion means calling itself. Recursion means solving bigger one in terms of smaller one. Next one, recursion internally uses stack data structure. Next one, every recursion should have termination condition, otherwise stack overflow error message will come. Next one function call to another function call, parameter value will change but not other things. Next one, for every recursion, non-recursion possible. For every non-recursion also recursion is possible. Next one, comparing recursion and non-recursion. Recursion will take more stack space because of more function calls. Right? Non-recursion will take mostly more stack space. Non-recursion will take less stack space. Recursion will take more stack space. Next one, recursive programs are easy to write, but they may take more stack space. Non-recursive programs are difficult to write. Right? Difficult to write, but the thing is they may take less stack space. Right? You know this very well. Computer like non-recursive program, users like recursive program. The number of stack units you will use while recursion is going on, that is called depth of the stack. Right? Some points. Whatever is there in your notes, I read one time. Right? Almost like 10 points are there. Please take care. Right? Now come back. Now. Everyone listen. Everyone now listen. Factorial of int n. Factorial of int n if n less than or equal to 1. If n less than or equal to 1, return 1. Else return n into fact of n minus 1. N into fact of n minus 1. Int n, if n is less than or equal to 1, return 1, else return n into fact of n minus 1. It is a recursive program, everyone know. I written one more time. Recursive programs are very easy to write because it contain only two parts. Recursive programs are very easy to write. If part, else part. Remember in the if part, else part, if part should come first. If you write unfortunately else part, right, it don't check it the termination or not. It will keep on enter into infinite loop. Infinite loop means stack overflow. In the programming, right, in the recursion, you don't go to infinite loop. You want to go infinite loop, but in between stack space is over. You will get the stack overflow error message. Sir, if termination condition not there, can I go to the infinite loop? Right? You want to go, but in between stack space over, it will stop. So in every recursive program, first part is termination condition. If termination condition not there, stack overflow error message. It's not infinite loop, it is a stack overflow error message because stack space over. You are trying to push infinite function calls, but unfortunately stack space is finite. You try to push infinite people, but stack space is limited. So in between it will stop and it will give error message stack overflow. Okay, this one everyone know. Now listen everyone. Everyone concentrate. This is going to be recursive program. Right? Now listen. This is the if part. This is else part. This is if part. This is the else part. This is the if part. This is the else part. Now let us assume factorial of n will give value. Assume factorial of n will give value. Otherwise I can write directly also. There is no problem. I am writing now. Listen. I am writing the same thing in another way. Can you see this one? I am writing same thing in another way. Can you see this one? Fact of n is equal to, same thing I am writing. See this one. Fact of n is equal to, someone asking what is fact of n. If n is less than or equal to 1, written 1. Fact of n is 1 if n is less than or equal to 1. Fact of n is equal to 1 if n is less than or equal to 1. Fact of n is equal to, if condition is fail, else part. What is the answer? N into fact of n minus 1 if n is greater than 1. If n is greater than 1. Right? Same thing I written. Right? First part I written first place, second part I written second place. See, first part I written first place, second part I written second place. So remember, recursive program if you write in the form of a relation, that is called recurrence relation. Same thing you write, you no need to do anything. First part write first place, second part write second place. But don't write in the form of a program, please write in the form of a mathematical notation. Fact of n is 1 if n is less than or equal to 1. Otherwise n into fact of n minus 1 if n is greater than 1. Writing recursive program in the form of a relation, that is called recurrence relation. It is called recurrence relation. That is called recurrence relation. That is called recurrence relation. Good evening, sir. Arey, Goyal, how can you come late? Goyal don't have common sense. How can you come late? Arey, Gootle. Right? This is the recursive program. This is the recursive program. This is the recurrence relation. So remember everyone. Remember. Recursive program you are able to write means recurrence relation also there. That is the reason people used to say that. Right? If you know mathematics, you know programming also. If you know programming, you know mathematics also. The person who is so good in mathematics is so good in programming also, because both are same. Write in the form of a mathematical function, that is called recurrence relation. Write in the form of a program, that is called recursive program. Every recursive program, recurrence relation possible. Every recurrence relation, recursive program also possible. That is the reason I see in somewhere computer science is started. Let us assume that computer science is started. Let us assume, I think to be frank, computer science is seriously started. Let us assume that computer science is seriously started. 2000 onwards, computer science is seriously started. Assume computer science is started 2000 onwards. Assume that. But some people are there, some faculty there in the computer science, they have 50 years experience. The reason is previously they are the mathematics professor. Before computer science professor, right? They are the mathematics professor. Right? Some mathematics professors are shifted to computer science professors because just writing the syntax and going to the computer science branch. What I mean to say is only computer science came 20 years back, but some faculty of computer science is 50 years old or 80 years old. The reason is previously they are the mathematics professors. Someone is saying, sir, how to be good in recursion? Just follow previous class, this class follow, you will be good. Previous class, this class follow, you will be good. So for every recursive program, recurrence relation is possible. So please careful. I'm thinking you are really comfortable. Just I will give some small idea. Listen everyone. I will give one small idea. Everyone concentrate. I will give just one small idea. Yeah, I'm giving one small idea. See correctly now. If I give n value 6, it will go like this. It became n value 5. 5 will go. And this 5 once again will go. It will go to 4. It will become 4. 4 once again will go. It will become 3. Can you help? It will call itself how many times? it will call itself how many times? Almost like f of factorial of 6 if I call, internal it will call 5, internal it will call 4, internal it will call 3, internal it will call 2, internal it will call 1, right? 1 is a termination, it will come back. So fact 6 will call fact 5, 5 will call 4, 4 will call 3, 3 will call 2, 2 will call 1, 1 will call no one. So this much stack required. Not only stack, see every function call will take some time, constant time. Every function call will take constant time. See this one, n function call. So time complexity n. So time complexity means how many times. Time complexity means how many times. Time complexity means how many times. How many times? I think 6 means 6 times, n means n time. So time complexity of factorial of n is, time complexity of factorial of n is how many times you called? N time. So time complexity order of n. How many times you called? N time. So time complexity order of n. And one more thing is, what is the stack space? Space complexity. Space complexity of fact of n is, space complexity of fact of n is how many function calls? How many function calls? N function calls. How many function call? N function calls. Because fact of n internally calling, n function call. Fact of n is n function call. So n function call. Okay. Every function call will take 2 bytes because there is a int n. Everywhere int n, 2 bytes. So 2 bytes. So finally 2n bytes. Finally order of n space. Right? Space complexity. Space complexity, stack space how much? Space complexity means stack space how much. So if anyone having small doubt, see this one. In the last class we seen fact 6 called, fact 5 called, and so on and so on. Lastly fact 1 is called. So 6 means 6 level stack required, n means n level stack required. So space complexity of fact n is, right, n function call, every function call is 2 bytes. So finally 2n bytes, finally order of n space. So time complexity of this factorial is n, space complexity n. Remember, space complexity concept will come. Space complexity concept will come, right? If recursion. If non-recursion, then nothing to discuss about space. In non-recursion, how many function calls are there? 1 function call. Sir, I have my last class doubt pending. Okay, you could have asked in the group. Then what you are doing in the group? The purpose of your group is asking doubts. The purpose of your group is asking doubts. You can ask in right. You can ask doubt in your group. I am there to help you. Thank you, Varun. Thank you so much. Thank you so much. The purpose of group is asking doubts. In the group, everyone is keep quiet, like right. In the group, if you ask some doubt, right, I will decrease your internal marks. You are behaving like I will decrease your internal marks. Then why are you there in the group? Yeah, that is those people who are already subscribed. Those people who are already subscribed, for them one group is there. If you are already subscribed, you can also join. If anyone is there here who is subscribed, if you are not there in the group, please let me know. I will join you. Right? Please, those people who are taken already subscription, please start asking doubt. Yeah, so Goyal, whatever doubt is there, post in the group. Goyal. Now again I'm asking you, space complexity is going to be interesting. Right? For the recursive programs. Non-recursive program, space complexity, because of only one function call, constant space. Only one function call, 2 bytes. Because one variable is there. Right? Non-recursive program, only one function call, one variable, 2 bytes. But recursion means stack space. Remember, space complexity question means space complexity means recursion. If non-recursion, nothing to discuss much. Recursion. Recursion means stack space. Recursion means stack space. Space complexity means it should be a recursive program. Recursion means stack space. Now in this program, I think n level stack is there. N level stack. Right? Every level 2 bytes. N into 2 bytes. So finally 2n bytes. Finally n. In this program factorial, n level stack, every level 2 bytes, 2n bytes, order of n. Now some people are asking, what about non-recursive program? Non-recursive program, just only for namesake I am writing. See this one. Fact of int n. Fact of int n. Inside. One for loop may be there. We written in the last class. For I is equal to 1, I less than or equal to n, I plus plus. S is equal to s into I. Lastly, printf s. Initially s is equal to 1. It is a program. Now if you observe this program, in this program see int 10 2 bytes. Next one, I think int s is equal to 1 2 bytes. 2 bytes, totally 4 bytes. One function call only 4 bytes. So order of 1. Every constant can be written order of 1. Int 10 2 bytes. Int s also 2 bytes, 4 bytes, order of 1. But when you see recursive program, int 10, see, only one variable may be, but it is going n time. Fact of n minus 1, fact of n minus 2, and so on. Fact of 1, almost like n function calls. Every one 2 bytes. So 2n bytes. Finally, order of n. Right? So please take care. Arey Goyal, post in the group. I created a group for your purpose only, you people purpose. You are not utilizing. Varun, if you have doubt, you can ask me personally. You are asking something else. You can ask me personally afterwards. So this month algo will be over. Plan properly. This month algo will be over. Please plan properly. This month algo will be over. Any doubt? See, non-recursion will take less space because one function call inside 2 local variables. Every local variable integer 2 bytes. 2 integer 4 bytes. But when you go for the recursion, more function call, every function call 2 bytes, more function call, right? I think more bytes. I was on time, sir. Okay, fine. That's okay. Please post in the group. Goyal. I am not seeing any message of yours in the group. I created group for your people only. You are not utilizing. Please start using. Arey Dinesh, you are not using. Dinesh, you are not using. Goyal, you are not using. Soumya, you are not using. Start using. Can I move to next? So every recursion you can write in the form of a recurrence relation. Every recursion you can write in the form of a recurrence relation. Every recursion you can write in the form of a recurrence relation. In the last class I explained what is recursion. 10 points I said to you. Now some more discussion. Arey Raz, how can you come whenever you want? Arey Raz, how can you come whenever you want? Will you not take I? Because we both are enemy. Because we both are enemy. To you and me some breakup is happened. That is the reason. To you and to me some breakup is happened. That is the reason. Will you not take me? Some breakup is happened between you and me. That is the reason. Oh, he is saying for space complexity, will you not take I? Oh, space complexity purpose. Okay, thank you so much. Space complexity purpose, why don't you take I? I taken, na? See this. Can you help me now? In the recursive program, I'm really sorry. I spoken so many nonsense lines, breakup, big up like this. Some nonsense things I spoken. Forgive me. Bhaiya, forgive me. See this one. In this program, if you observe, see, recursive program, nowhere I there, see. Recursive program, nowhere I is there. See, I not there. No I, na? In the recursive program, no I. But in the non-recursive program, I there, see. In the non-recursive program, I there, yes there. Oh, I also there. Sorry for this. Here you are talking. I. Yeah, you can take 6 bytes. That is also constant, na? Sai, you are correct. Yeah, true. Right? I also 2 bytes. So let me write now. Int S, int I also. But finally same, na? Int I, int S, int N. Totally 3 people. 3 people, 6 bytes. So order of 1. You are correct, Sai. Sai, right, there is no breakup between you and me. We are best friends. You are my younger brother. No breakup, nothing. You are my younger brother. Nice boy. You will get afterwards. Yeah, I give an answer. I already given. Right? So totally 6 bytes. I already explained. Totally 6 bytes. So recursion, right? Every function call is 2 bytes, like that n time. In the non-recursion, only one function call which contain 3 people. So everyone is 2 bytes, 3 people, totally 6 bytes, which is nothing but order of 1. If you okay, we can go to the next one. Anyone having any doubt, please let me know. Anyone having any doubt, please let me know. Anyone having any doubt, please let me know. Someone is saying, sir, how to write? Sir, how to write the recursion? See this one. First one, right? First statement, copy as it is. Second statement, copy as it is. That is become recurrence relation. First one, copy as it is. See this one. First one, I copied as it is. First one, you copy as it is. Second one, right? So see, first one you copy as it is. Second one you copy as it is. Right? Then recurrence relation came. Hi sir, how are you? I am fine. Yeah, next question. Fine. Perfect. Can we move to next? Can we move to next? Yeah, let's go to the next one. Let's go to next one. If you are seriously preparing for GATE CSE, if you are seriously preparing for GATE CSE, if you are seriously preparing for GATE DA, if you are seriously preparing for a DSA, my suggestion is please join EPT. Exam prep tool you can join. Trust me. Finally you will get the nice thing. Join as soon as possible. Right? I will make sure within 6 months total syllabus will be over. You will do lot of practice. You have approximately 5,000 practice questions are there. 5,000 practice questions are there. Test series also there. Rank improvement course also there. Right? So those people who are serious, they can join here. Go to exampreptool.com website, you can subscribe. Or you can WhatsApp me also. I will help you. If you are serious, this is the correct place. If you are not serious, you no need to waste your money. It's a hard earn, right? Mama, papa took a lot of time to earn them. Lot of hard work they done to earn. If you are not serious, you please don't join. Right? What is the reconciliation for finding time and value? Now itself you don't get RAS. You don't get that. I cannot spoil the people life for you. It will come afterwards. Now go to the next problem. I am thinking you are really fine. Let's go to next problem. Next example. Example 2. Write down now. Write recursive program, recurrence relation. Write recursive program, recurrence relation to find multiplication of 2 positive integers m and n. Whatever you know, right? If you know both, say both. If you know only one, say only one. Whatever you can, you say. In the interview, whatever you want, whatever possible by you, you say. Both are okay. Whatever you feel, you can say. Write recursive program, recurrence relation to find multiplication of 2 positive integers m and n. I will explain. Write a recursive program, recurrence relation to find multiplication of 2 positive integers m and n. So I am explaining. Everyone can listen. Everyone. It is the second problem. One problem we done. It is the second problem. Please concentrate properly. It is the second problem. Please concentrate properly. Write recursive program, recurrence relation to find multiplication of 2 positive integers m and n. Everyone concentrate. Everyone concentrates. What I am going to say, concentrate everyone. If you want to write the recursive program, recurrence relation, right, to multiply 2 positive integers m and n, right, what you have to do is first to take one example, right? Let's explain example. I am explaining one example. Can you see this one? I am explaining example. This may be the problem P. So I am taking one example to explain this. Right? It is a one problem. To solve this problem, I am taking one example. See how I am taking. Everyone listen. M is equal to 10 assume. N is equal to, right? Let us assume that n is equal to 4. M is equal to 10, n is equal to 4. So m into n, which is nothing but 10 into 4, which is nothing but 40. So how to get it? So everyone know m into n is nothing but M into N is nothing but adding M n times. Adding M n times. Everyone know addition, right? Multiplication is nothing but repetitive addition. Recursion means repetition. Recursion means repetition. Can I write this problem in terms of repetition? Please verify. When you say multiplication, repetitive addition. Sir, why should I do repetitive addition, sir? Recursion means repetition. Recursion means repetition. Sir, I have to do multiplication. Why are you writing repetitive addition, sir? You want to write recursive program. Recursive program means repetition. So, can I write multiplication in terms of some repetition? Oh, repetitive addition is multiplication. Repetitive addition is nothing but a multiplication. Adding M n times. Adding M n times. So, if you okay with this example, see how I am writing. Everyone listen. If you are okay with this example, see how I am writing. Everyone listen. Multiplication of 10 comma 4 is equal to, careful, multiplication of 10 comma 4 is equal to, add 10 one time, remaining multiplication of 10 comma 3 times. Namaskar. Can you go to the next one? Multiplication of 10 comma 3 can be written as because of recursion. Same story. Add one more time, 10 plus multiplication of 10 comma 2. Multiplication of 10 comma 2 can be written as 10 plus multiplication of 10 comma 1. Right? Again this can be written as, listen, again this can be written as, everyone listen, again this can be written as 10 plus multiplication of 10 comma 0. But everyone know, when you are multiplying two number, if one number is 0, answer is 0. When you are multiplying two number, if one number is 0, answer is 0. Every recursive program requires termination condition. So this is 0. 10 plus 0 becomes 10. So in the return, it will go to 10. From which place you came, that place 10 will go. 10 plus 10 becomes 20. 20 will go here. 20. 10 plus 20 becomes 30. 30 will go here. 10 plus 30 becomes 40. 40 will go here. So finally 40 came. Finally 40 came. Recursion is nothing but repetition. Please remember everyone. Recursion is nothing but repetition. If anyone not start studying, please study. If you are not start studying, please study. Please study. At the end of this year, I want to see you with more knowledge. Please start asking doubts in the group. Doubt asking is the first point of learning. Doubts asking is the first point of learning. You should learn. See, slowly I am going. In next month maybe, at a time 2 or 3 subjects will come. In the next month 2 or 3 subjects will come. It will be so hectic to you. Please follow this properly. Multiplication is nothing but repetitive addition. Sir, why repetition? Recursion means repetition. So I find out one logic where repetition will come. Oh, multiplication is repetitive addition. So I written the multiplication in the form of addition. I written. If you are comfortable, what is the termination? Multiplication of two number. If any number is 0, right? So that answer is 0. Good evening, boss. I am waiting for an hour today morning. Oh. Why are you waiting? You could have studied by your own. Why are you waiting? You could have studied your own. You could have waited, right? You could have studied your own. Right? Tomorrow pakka. Arey Jay, tomorrow pakka. I thought you people may not come. So, because of, right? So that may be the reason I left the class. But anyhow, tomorrow pakka. Yeah, can you come to the next story? I think because of you are really comfortable. See the program everyone. Multiplication of, see the program everyone. Multiplication of m comma n. See the answer. Multiplication of m comma n inside. Multiplication of m comma n inside. If listen everyone now. If m is equal to 0 or n is equal to 0, m is equal to 0 or n is equal to 0, what is the answer? If any one is 0, answer is 0. That's okay. Else if no one is 0, then answer is return multiplication of, right? Multiplication of m plus return, let me write here, return m plus one time add multiplication of m comma n minus 1. That is the answer. It is a recursion. If m or n, any one 0, return 0. Else return m plus multiplication of m comma n minus 1. Why n minus 1? One time I already added. So n minus 1 times I have to add. If I add one more time, it will become n minus 2. If I do one more time, it will become n minus 3. Keep on decreasing. Some point of time, n value become 0, then return 0 will come. Someone is saying, sir, shouldn't we take, right, the one which will take less in recursion, right? So I am saying recursion, right? I am not saying good recursion, bad recursion. I am saying recursion. Goyal, whatever you are asking is really good. Why m is equal to 0? It will take no effect. Yeah, suppose assume that Goyal, suppose assume that maybe they are given both zeros. Suppose input itself is given zeros, then you can stop. Right? Input itself is 0. Suppose input itself is 0, both are 0. Then m is equal to 0, n is equal to 0, anyone satisfied? Okay. Whatever you are saying, that is also correct. I am writing one way. You are also correct. Right? But I am thinking that if anyone give unknowingly both the zeros, any one 0, simply return 0. Right. You are also correct. It is unnecessary, but some people may give, right, both 0. Then I think to solve that also I given. So if anyone is 0, return 0, else return m plus multiplication of m comma n minus 1. Right? Fine. Perfect. Now see this one. Listen, same thing, map in the form of a recurrence relation. See how I am writing recurrence relation? See how I am writing the recurrence relation? Recurrence relation. See this one. Multiplication of m comma n is equal to, as it is copy. Multiplication of m comma n is equal to, answer is 0 if m is equal to 0 or n is equal to 0. If any one 0, return 0. Suppose no one 0, come to the else part. Same, m plus multiplication of m comma n minus 1. Otherwise means, right, these are other cases. Otherwise means else. See this one. First part. Second part. Nothing there. As it is copy. I am not writing the best recursion, I am not writing the worst recursion. I am writing one recursive program. Right? Please careful. I am writing one recursive program. See, this is the logic which I followed. Adding m n times. This is the logic which I followed. Adding m n times. Right, see, finally I written the recursive program and recurrence relation. See, if you start slowly writing, you write the recursion, you write the recursive program, many things you learn. Next month, this time, trust me, you have lot of knowledge. The only thing is, every class improve. Next month, this time, you will have lot of knowledge. The only thing is, please improve. Are you okay with this problem? Some people are asking, sir, you are stopping at 0. Can I stop at 1, sir? You can stop. One termination condition required. There is no fixed termination condition. Different people will write the termination condition different ways. Some termination condition required. Sir, I want to stop at 1. Yeah, you can stop. Sir, I want to stop at 0, sir. You can stop. Stop wherever you want, but do corresponding changes. Stop wherever you want to do corresponding changes. You only say m into 1, m. If you stop at 1, return m. M into 0 is 0. If you stop at 0, return 0. Wherever you want, you can stop. Sir, can I stop at 0, sir? Yes, you can stop. M into 0 is 0, then return 0. Sir, can I stop at 1, sir? Yes, m into 1 is m, return m. Fine. So there is no fixed termination condition, but one thing, termination condition required. Which termination you write? Whatever you want. Every recursive program should have termination condition. And one more thing is, listen, I written the recursion to my logic. See, first of all, I written the logic. See this one. I written the logic. Whatever logic I written, to that logic I written the example. Whatever example I given, to that I written the program. I followed some procedure. There may be so many logics. For one problem, only one recursion. No. Different people will write different ways. For one problem, should I write recursion one way? There may be many ways. See, I written here. See, m into n is adding n time. One more logic also there. Adding m times. You can write the same thing like this also. You can write the same thing in another logic also. See the another logic? You can write like this also. Right? Another logic you can write how? Adding n time or adding n times. M times. That is also correct. Remember, one problem may be having so many solutions. Adding m times, that is also okay. But adding n time, that is also okay. First of all, find out which logic you want to write. Okay, I took this logic. Red color, whatever I written, that logic I taken. I given the example accordingly. I written the one recursive program. I written the recurrence relation. If you write the different logic, so different recursive program. One problem have many recursive programs. Else case m greater than 1, n greater than 1. Can be read? Of course. Otherwise means same meaning. Otherwise means MC. Otherwise means other than that case. What is the answer? If m is greater than or equal to 1, n is greater than or equal to 1. M greater than or equal to 1, n greater than or equal to 1. If you keep quiet, you never grow. If you have a doubt, if you keep quiet, you never grow. I want to see you growing person. I want to see from your side growing person. If you keep on asking doubts, then only you are growing. You have doubt, ask. There is no internal marks. I don't cut internal marks. In the BTech, if at all it is a BTech, right? I am your college teacher. I am your college professor. If you ask doubt, I may decrease the marks. What I will decrease here? You paid amount. You paid the money. Please do justification. You paid the amount. Please do justification. If you don't get, ask me. If you don't get, ask me. Are you getting? If you don't get, ask me. That group is created for you. You have to keep on ask doubts. So if you okay with this, we can proceed further. One problem having many logics. So if anyone asks you from today onwards, for this problem please write the program, right? For this problem please write the program. First of all, check what logic you want to write. Verify. Okay, adding, multiplying two numbers, multiplying m into n. M into n can be written as n into m also. M into n can be written as n into m also. Adding m n time or adding n m time. There may be many logics. So I written one logic. For my convenience, whatever I felt, I written. So this is the logic. See, m into n, adding m n time. So this is also one more logic, but I didn't written. Now itself I don't want to write best algorithm, worst algorithm like this. I don't want to do. Just I want to give one recursive program. Can you see the write recursive program recurrence relation to find the multiplication of two positive integers m and n. So like that. Yeah, if you all people say yes, then I can proceed further. If you all people say yes, I can proceed further. If you are okay, please say yes. If you okay, please say yes, then I will proceed further. If you are okay, please let me know. Please say yes if you are okay. Everyone. I want to see everyone. Right. Perfect. So recursive program, recurrence relation. Now listen. In this program, if you observe, adding m n times. Listen, adding m n times. See this one. N is keep on decrementing. If n is initially 4, next 3, next 2, next 1, next 0. Adding m n times. 0 fail. See, adding m n times. So time complexity. How many times? Time complexity is how many times? Time complexity. How many times that loop is going on? Remember, recursion also loop only. Time complexity is n times you done. Adding m n times. So time complexity order of n. Loop is how many time? Time complexity order of n. Loop is how many times? Even though m and n both are there, but loop is how many times? Loop is n times. So time complexity order of n. Remember which logic you taken, to that logic time complexity. If you written the program for one logic, you cannot say time complexity for some other logic. If you written the program for logic x, you cannot find time complexity logic y. Which program you written, that program only time complexity. Time complexity of this program is, right, n, order of n time. Time complexity of this program is order of n time. Are you okay with this? Time complexity of this program is n times. Can you see the space complexity? Recursive program means space complexity will come. Non-recursive program, no space complexity. I never seen a program where non-recursive program space. Non-recursive program is one function call. One function call internally contain maybe 5 local variables. 10 local variable, 20 local variable, nothing else. So anyhow, space complexity. Can you see the space complexity? So if you observe clearly, see n time. See this one. I think this is the one function call. This is a one more function call. This is a one more function call. This is a one more function call. Right? I think right F1, F2, F3, F4. It is the termination. If you don't write also no problem. I think almost n times. So I think n plus 1 level stack. N plus 1 level stack. Finally, n plus 1 every level some constant space. maybe some local variable, 2 local variable, 3 local variable, whatever it may be, some constant space, n plus 1 into constant, finally nc, where c is a constant, so order of n space, order of n space, because every function will take constant space. One function call will take constant space, that may be 2 bytes, that may be 4 bytes, that may be 10 bytes. N plus 1 into c, forget about small constant, order of n. N plus 1 level stack, right? Because 4 become 3, 3 become 2, 2 become 1, 1 become 0, 0 is stopping point. If you want, you can write n level also. Forget about minus 1 plus 1, don't concentrate on plus 1 minus 1. If you learn minus 1 plus 1, you never grow in your life. How many levels stack? I think see this one. I think multiplication of 10 comma 4 is called. It became 10 comma 3. It became 10 comma 2. It became 10 comma 1. It became 10 comma 0. 0 is termination. Including this also, totally almost like 5. 4 given, n value 4 given, approximately 5. Approximately 5. So n plus 1 level stack, right? One stack unit will take constant space. So n plus 1 stack units, n plus 1 into constant, finally nc, which is nothing but order of n. Now very important question I want to ask you. When recursion is going on, are you using one stack or many stack? Can you type in the comment section? When recursion is going on, right? Are you using one stack or many stack? Can you type in the comment section? When recursion is going on, you are using stack, I am fine. You are using stack, I am fine. But how many stack? Yeah, so Goyal, remember this. Time complexity based on how many times? You will get more deep afterwards. Goyal, complex programs will come. We will discuss complex way. That's what I'm saying, right? Don't talk big lines, right? Complex programs will come, complex way I will discuss, right? Very soon you will go to more deep. In the recursion you will die. In further classes, in the recursion you will die. These are small program. I don't want to make complex now itself, right? Further programs will kill you. Everything is recursion only from now onwards. I cannot escape, you cannot escape. Further programs will kill you. You will swim, right? You will do swimming inside the recursion. Inside the recursion you will go to swimming, right? These are small things. Don't make complex here. Because of these are small program, right? Time complexity is how many times? When further big programs will come, there you will go to the flooding, right? Recursion flooding will come. In the flooding, right? You will die also. Recursion flooding will come, you will die there. Right? These are small recursive program. I don't want to make a small recursive program complex way. How many times? Time complexity means how many times loop. Recursion also loop only. How many times loop? Right, perfect. Let's go further. I am thinking that you are almost okay. Go to the next one. Next problem. Write Write recurrence relation, recursive program to find GCD of m comma n. Write recurrence relation, recursive program to find GCD of m comma n. Yeah, so can you help in our previous problem, listen, in our previous problem, one stack or many stack? See, Dinesh is written many stack. Are Dinesh, where is many stack yaar? Where is many stack? Can you see this? Dinesh, can you see this one? Where is many stack? Are Dinesh, where is many stack yaar? See, one stack only. When recursion is going on, one stack, many units. These are stack units. One stack only you are using, one stack only, but many stack units. One stack contains so many slots. You are using many slots, but one stack only you are using. You are using one stack only, not many stack. Right? Whenever recursive program is running, you are using one stack. In that one stack, many stack units you are using. When recursion is going on, you are using many stack units. When recursion is going on, you are using many stack units, but remember, one stack only you are using. Recursion going on. If anyone say multiple stack, how to combine all of them? Suppose one function is pushed into one stack, one more function is to another stack, one more function to another stack. Then how to combine them? No. See, if you keep all the people in different stacks, how to combine them? Suppose that one function call in one stack, another function call in another stack, another function call in another stack. Then how can I combine them? How can I link them? See how the linking. If you keep in one stack, see the advantage. If you keep in one stack, advantage is, see this one, advantage is function calling, see this one, function calling, they will go like this. If you keep in one stack, function call, push, function over, pop like this, function over pop means come to next slot, function calling is push, go to next slot, calling means go to next slot, over means go to previous slot. If you keep everything in one stack, advantage is calling, push, next slot. So whenever it is over, previous slot. So like that, synchronization is very simple. If you keep in multiple stack, unnecessarily you are wasting so many stacks. If you keep multiple stack, unnecessarily you are keeping many stacks. Unnecessarily keeping many stacks. Fine. Only one stack we are using. One recursive program is running, one stack is enough. Right? Perfect. I'm thinking you are really comfortable. Right? Yeah. So remember, write a recurrence relation, recursive program to find GCD of m comma n. One more problem. Write recurrence relation, recursive program to find Fibonacci of n. Fibonacci of n. Fibonacci or Fibonacci? Fibonacci of n. Yeah. So remember, see this one. These two are homework. Write recurrence relation, recursive program to find Fibonacci of n. These two are homework. In tomorrow, right, I will keep the one recorded lecture. Where all these answers will be there. You first try yourself. Right? All these answers will be there. Right? These two things I will make the recorded video, I will keep to you. You first try by yourself. Yeah, that's what I am saying. Right? You please try yourself. Right? If anyone don't know how to find GCD, first calculate. See some samples. How to find out GCD. Right? These are very, very dangerous problems. Right? Right? These two problems first to find out. Right? Afterwards, I will explain. You will get more clarity. Right? So tomorrow onwards, all numericals will come. Because of the theory, I took a live class. Because of the theoretical part, I took the live class. Right? So tomorrow onwards, all numerical examples will come. All will come in the recorded. Numerical problems will come. All will come in the recorded. So I will keep tomorrow onwards. All will be recorded. Right? Until maybe next Saturday, Sunday. Once again live may be there. Right? So yeah. So next one, most probably this month end, right? Total algo will be over. Please be comfortable with all of them. Right? This is the homework to you. Everyone try. This is the homework. You have to write your own notes. Right? Goel, find time complexity also, space complexity also. Whatever possible you try. Find time complexity also, space complexity also. Whatever possible you try. Recursive program, recurrence relation, time complexity, space complexity, please try. Okay? Fine? Yeah, next one. If anyone is not joined, if you are serious about GATE exam, go to exampreptool.com, you can join there. Or you can WhatsApp me also. And those people who joined in your group, start asking doubts. If you are serious about GATE CSE, join GATE CSE. If you are serious about GATE DA, join GATE DA. If you are serious about DSA, join DSA. DSA contain DSA lectures followed by competitive programming. Followed by system design also. I am planning system design also. Even I didn't promise, right? I will do more than promised. Trust me, I will do more than promised. Whatever I promised I will do more than that. My only goal is I want to make sure you will be successful in your life. That is the purpose of this EPT and all. That is the reason I started. Right? Anyhow, right? In tomorrow's class you will see right? These two homework whatever I given plus 20 or 30 problems are there. 20 problems are there approximately 20 problems are there. All I will solve. Approximately 20. Sir, I think chat is disabled in our private group. No, you can chat, right? Raj, you can chat, na? Goyal, can you chat or not? Goyal, can you chat or not? You people can chat or not? Yeah, mostly you are correct. Right? Please take care. Take your own time. I will explain anyhow. You can compare. I have not tried. Yeah, you people try. Please start asking. Please start asking. See, that is the starting point of growth. If anyone is typing the doubts, means you are improving. You are improving. You no need to hide your doubts. Any problem is there, please let me know. I am your elder brother. I am your elder brother. Any doubt there, let me know. Sir, it is saying text is not allowed. Are allowed, yaar. Maybe is there in another group. Yeah, Raz, can you ping me once? Raz, you ping me once. I will help you. Yeah, if anyone didn't like this class, please like this class. Please like it. If you don't like it, right? If anyone is not like it, please like it. That's what I am saying. That's what I am saying. Raz, you please ping me. I will help you. If anyone didn't like, please like. Please inform to your friends also. Those people who want to join, please inform to them also. Please inform to them also. Thank you so much. Thank you so much. From tomorrow onward, 3 or 4 classes. 3 or 4 classes. All are numerical. All are numerical. All will be there in the app. I will keep in the app. In app recorded, right? Recorded I will keep. So it will be over immediately. Right? Perfect. Yeah. Thank you so much. See you in the next class. Good night. So it is not required. Aviral, it is not required. Right? Last 20 year one time also not asked. Why you want to study? Whichever needed I covered. Chalo. Good night.